Hi math fans, and welcome to another edition of Math with Mr. Douglas. In this episode, we will be looking at 4 different situations for systems of equation word problems. Yes, we'll be looking at age questions, we'll be looking at questions that involve rivers or space or airplanes going back and forth, coins, which are always interesting depending on where you are from. And last but certainly not least, we'll be looking at flipped digit questions because, you know, you're always wondering about flipped digits. So let's get to it, jump into hyperspace, and off we go. So now we're going to take a look at coin questions. Yes, what kind of currency are all those things like nickels and dimes and quarters? What is it? Loonies and toonies? This is interesting stuff. All right, let's get to it. So imagine that Darth Vader actually carried around a wallet. I don't know where he would put his wallet. Underneath his cape, I guess. But imagine he did, and he had 42 coins consisting of dimes and quarters. Now, there's a few things. We need to know things about money, and we're going to use the North American terms. So a penny as a decimal is 0.01. We have nickels. A nickel. We have dimes. We have quarters. Now, if you're really lucky and you have a Canadian teacher, you have things called loonies. And I kid you not, you have things called toonies. Toonies. I think it's spelled that way. It might be spelled toonies, like this. Toonies. I'm not too sure. But the important thing to know is as decimals what they actually are. So a nickel is 0.05, a dime is 0.1, a quarter is 0.25. A loonie is another word for $1. And if that's a loonie, a toonie is $2. And this is in Canada. When you're talking about coin questions and systems, you're always going to get one equation that is the total coin. So that's going to be really easy. The other one is going to be where you're going to have to multiply the amount of coins times the value. Okay, so that's what you're going to be doing. So taking a look at this, Darth has 42 coins. They're dimes and quarters. Okay? Well, what do you want things to be? I want X to be dimes and Y to be quarters. If they are 42 in total, then you know that X plus Y is going to be 42. That just makes sense. The second equation is always the hard one. The second one is going to require you to multiply the amount times the value. The total value of the coins is $6. Now you have no idea how many dimes there are, and you have no idea how many quarters there are. But you know they equal $6. So if X is dimes, and dimes are 0.1, it would be 0.1x. Plus the quarters, 0.25y, and that's going to be equal to $6. So there you go. There are your 2 equations. This is one of those situations where I would actually use substitution, and I would solve this equation for y. I would subtract x from both sides. So y equals 42 minus x, and I'd put it right down there. So I would end up having something that said 0.1x plus 0.25 times y, which is 42, minus x, is equal to 6. And I would go and I would solve that for x. So what do you end up getting? You get, obviously, some really fun numbers. you're going to get 0.1x. And I don't know if I need to, do I need to go on to another page? I might need to. 0.1x plus, that will give you 10.5, minus 0.25x is equal to 6. I'm going to try and squeeze this in. I think I can do it. So, minus 0.25x plus the 0.1x would give you negative 0.15x. So you'd have negative 0.15x would be equal to a negative 6 minus 10.5, negative 4.5. Like that. Divide both sides by 0.15. And you would get 30. X is equal to 30. So x equals 30. So you know that there are 30 dimes. So there you go. 30. If there are 42 coins in total, then there must be 12 quarters. And there you go. That's how you go and do coin questions. We all know the Millennium Falcon is the fastest ship in the galaxy. So, what happens if it goes upstream and downstream and crazy things are happening? Let's go and figure that out for systems of equations, shall we? Well, now we're going to be talking about the classic problems that I find kids struggle with the most. And I like to call these river problems. Sometimes they're air problems. This is basically where you have like boats going up and down streams, or you have airplanes that are flying against the wind or with the wind. Yes, that's an airplane right now. It looks like a bird, but it's an airplane. So these are the types of questions, and I'm going to just change this into a Star Wars X-Wing question. And it makes no sense because space is a vacuum and there's probably not any wind, but just imagine that there is, just because I want to make this an X-Wing question. Okay, so an X-Wing took 3 hours to fly 1,800 kilometers in the direction of the solar system, so that's with the wind, and then against it took 4 hours. So what was the speed in still air and the X-Wing speed? So a couple of things. So we need to talk about this in general a little bit. So in general, when we are talking about these kinds of things, I like to go and reference the pyramid. And this is my distance, speed, and time pyramid. So there's D, and there's S, and there's T. So this solves everything. So distance is equal to speed times time. Speed is equal to distance divided by time. And time is equal to distance divided by speed. And this is actually done in the actual pyramid. So you can see like this is the actual dividing. And you can also see that this is the actual timing, T for timing. So distance equals speed times time. So this pyramid is really, really cool. It actually tells you how to go and solve all those kinds of things. And you have to realize that when you do get these questions, you have to ask yourself, what are you not told? And what is equal? That is going to be very, very important for these kinds of things. So you have two different situations going on. The other thing to think about is obviously if you are in an X-Wing. So here's my, you think I'd be able to draw an X-Wing, but actually it's pretty hard. It's actually easier to draw probably from behind because of the way everything opens up and stuff. But here's my X-Wing. That's a horrible X-Wing. Here's R2-D2 in the back. How about that? That worked. There he goes. R2. R2 is half the size of the X-Wing. But anyways, when it's going this way, there are two things that are happening. It's flying, so you have the ship speed, and you either are going with plus or against the wind. My example when I talk to students in person is imagine you're in an airport and you're on those little people mover things and you get on them and like boom, you're like just running down the airport, right? You're going with the little people mover thing. But as you see those like little 6-year-olds who like turn around and they try and run against it, that's going against it. So that would be subtracting. So that's kind of the idea to think of when we are all looking at this stuff. So here's a question, and now we just need to go and basically go and figure everything out. So let's go and, whoa, I didn't know I could go and erase that. That's pretty cool. So let's go and actually try and figure out this question. And when we're making up our equations, you really do want to be thinking about, I really should have put all these pictures on a different layer. It would have been easier than erasing. Think about what's happening with your distance, speed, and time. So I'm going to make x b, and actually, let me just go over here. I'm going to make x equal the x wing speed, and I'll make y be the speed of the air. So those two things. That's where we're going to be going. So it took 3 hours to fly in the direction with it. So we're going to be going with that. So the distance is going to be 1,800, right? And distance is equal to speed times time. So the time is 3 hours, and it went in the direction with it. So 3 hours, that's the time, and then the speed for this one would be x plus y, because you're adding them together. On the way back, though, it went against it. So if it went against it, it took 4 hours. So again, the time is 4, and the speed, though, this time is the x-wing, but it's going to be going against the wind, so it's going to be x minus y, and it still took 1,800, just like that. Okay, so can we go solve it now? Well, a couple of things is you're going to have to go and there's some shortcuts, but I'll show you. Most kids are going to go and probably distribute the brackets for this one. And they're going to get 3x plus 3y is 1,800. And then 4x minus 4y is also 1,800. Okay. So you're going to use probably either substitution or elimination. And I'm going to go and eliminate, because that's just fun. And let's go and eliminate the x's, perhaps. So I'll make these all be 12, so I'll times this by 4. So this would be 12x plus 12y. 4 times 18 is going to be, what's that, 40, 72, so that's going to be 7,200. So I write down my 7,200 really small. And the other one, I'm going to times by 3. So 12x minus 12y. I times this by 3, so I think that's going to be 4,800, I think. But I always like to make sure. Oh, no, it's going to be 5,400. 5,400. There you go. Like that. Okay. Perfect. Let's go and eliminate this by subtracting. So 12 minus 12, the x's are gone. 12 minus minus 12, ooh, tricky. That's going to be 24y. And I'm subtracting. So 72 minus that, 54. And I'm going to get 1,800. And I'm not done yet. I need to divide both sides by 24. And when I do 1,800 divided by 24, I get 75. So y is 75. I'm going to put that up here just so I know my speed of my air is 75. That's exciting. Now I need to go and substitute. So I'm going to go and substitute that, that 75 somewhere. I'm just going to go right into there. And when I do that, this is getting pretty messy now. So I would get 12x plus what 12 times 75 is. So 12 times 75 would be 900. And that would be equal to 7,200. And I would subtract 900 from both sides. And when I subtract 900 from both sides, I would get 6,300. And that would be equal to 12x. I would divide by 12. And I would get x is 525. And that's going to be the speed of my x-wing, which sounds about right. So my x-wing was traveling at 525 kilometers an hour with an extra speed of 75 by the wind. So that's how you set them up. There are many different questions. I can give you probably like 5 or 6. You want to try different ones where different things are unknown. So definitely do lots of practice on these ones because these are the ones that typically trip up students. And last but certainly not least, how do we go and buy tickets to one of the Imperial balls? Yes, I heard there is a huge wedding happening. Who is Luke Skywalker going to marry? Is it going to be Mara Jade or somebody else in the galaxy? And why is it an Imperial wedding? These are great questions. Let's go and figure those out, shall we? Here we go. So today we're going to talk a little bit about a bunch of different types of problems, and the first one we're going to be looking at is money problems. So here we go. Let's take a look at a real life situation that could totally be happening. The first order placed 2 orders. That's funny. With a shipping company, the first order was for 13 TIE fighters and 4 Star Destroyers. And so some of you are like, what is he talking about? Star Destroyers and TIE fighters. So TIE fighters are the ones that kind of look like this. And the Star Destroyers, there's a whole bunch of different kinds of Star Destroyers. There's like the Super Star Destroyers. This is pretty important stuff, but this is like Star Destroyer. And it's really, really big. This is not to scale. This is not to scale. But those are the Star Destroyers. And altogether, he spent 487 Imperial credits in millions. The second order was for 6 TIE fighters and 2 Star Destroyers, in total 232 Imperial credits in millions. How much is one of each? That's what I want to know. So we're talking about systems. So, of course, we need to go and make our variables up. And I'm going to use, I'll use F for TIE fighters. So TIE fighters are F, and I guess I'll use D for the Star Destroyers. And when you're thinking of systems, you want to basically try and capture both situations. So the first situation is 13 TIE fighters, so 13F, and 4 Star Destroyers, so plus, that's my plus sign, 4D, and that equaled 487. I'm trying out a new pencil on my tablet, and I don't know if I'm liking this one right now. It's a little bit light. And the second time was 6 TIE fighters, boom, 6 TIE fighters, and 2 Star Destroyers, 2 of them. And that was equal to 232. Okay, so that's your 2 systems. And now to solve those, you can use different variety of tools. I would hope you would start to recognize that you'd want to use elimination, and you'd want to make your D's be the same. This is what you'd want to make the same, because I can easily double the blue equation. I can easily double this. So hopefully you can kind of recognize that. You wouldn't choose F's because F's, or sorry, the F's. Why did I put T there? I guess for TIE fighters. This should be an F. There we go. You wouldn't want to use the F's because that would be kind of awkward. So let's go and change our blue equation. Let's go and change that. So let's go and get rid of all this kind of stuff. So we're going to go and change that blue one. So I'm going to double everything. So I'm going to multiply this entire thing by 2, this entire thing. So like this would become 12F. This would become 4D. And of course, I had to double this. That would become 40. This is supposed to be 232. Like, what is happening? So if I had to go and double 232, it becomes 464. So there we go. Can you guys even see that? This is just not a very good
This is not a very good, clear question right now, is it? So 12, 4, and 464. Let's go and do that right now. So I'm just going to go and erase this so it's nice and clear. The great thing about technology is I can just erase things and move along. Move along, move along. Quick, what movie was that from? And who was saying it? So if I doubled everything, I would have had 12 TIE fighters, and I would have 4 Star Destroyers, and that would have equaled, I believe, 464. Okay. Are you going to add or subtract? What are you going to do? I'm going to go and I'm going to subtract. 13 minus 12 is just going to be 1F. I like that. 4 minus 4 is going to be 0. And I'm going to subtract this one. And I should get, let's see how I do all that, 3 to 23. Woohoo! So F is 23. I'm just going to go and write that over here. That makes me happy. Now, let's go and do some more stuff. I need to go and put this 23 into one of these equations right here. Which one am I going to go and choose? I'm going to go and choose Rome right there. So this is 13 times 23. And I'm sure you're like me and you can just do that in your head, right? Boom. Or you can be like me and have to go and grab your calculator right now. And I'm going to do 13 times 23. I've got my handy dandy calculator, and it says that when I do that, it's 299. So you ended up getting 299 plus 4D is equal to 487. Okay, I'm going to subtract 299 from both sides. And that is going to leave me with the 188. And then, of course, I'm going to divide both sides by 4. And I'm going to have what my Star Destroyers are. And we love Star Destroyers. And that is going to be 47. So, 47 Star Destroyers and 23 TIE Fighters. That sounds like the cost of each one. So that's not, of course, how many of each one, how much they cost in Imperial credits in millions. So 23 million for a TIE Fighter and 47 million for a Star Destroyer. A great deal. I would highly recommend buying some of those bad guy ships.
Thank you for sticking with us through this entire look at systems of equation word problems. Yes, a little bit of a Star Wars theme. I hope you enjoyed and you have a good idea of how to tackle all those typical situations you see in the galaxy. Until next time, have a great day.